Yeah, thanks for coming. This is a one-page proof of Fermat's last theorem with the famous drawing that Fermat couldn't put in the margin of the page. And we're using Fermat's right triangle theorem to prove this last theorem. Okay, so here's the triangle for the right triangle theorem. And we have four lengths. W is equal to z to the n over 2 minus an alpha, because we're going to set e to be the integer maximum for x to the n over 2. And I is the integer maximum for y over n over 2. So that the for e and I, the decimals after the integer have been lopped off. That means that w is going to be smaller than z to the n over 2. Because when you multiply it out, it's going to be zn plus some integer. Okay, that's what this means. It stands for the longest integer value of x. Okay, so w, okay, so e is an integer, I is an integer. This e is an integer also. Fermat's right triangle theorem says that out of the fours, w, e, I, and r, one of them has to be irrational. So what we're going to show is that both w and r have to be rational. So the original assumption that one of these letters is rational is wrong. Thus proving Fermat's last theorem. Okay, so w is equal to z to the n minus a, okay, from up here. Okay, where alpha is between 0 and 1. Okay, so w squared is equal to z to the n minus 2 alpha z to the n and a half plus alpha squared. Okay, so the factor in here where you have minus 2 z to the n over 2 has to be a rational number. Otherwise, e squared plus I squared are two integer values, and therefore there's a contradiction if that is not net rational. So w is an integer value because n over 2 is a rational number from over here. Okay, similarly, r squared is equal to I squared minus 2I beta plus beta squared. Again, the I has to be, makes the r squared a integer number. So r squared is rational, and because 2I beta it has to be rational implies that r is rational as well. Okay, because here's y to the n over 2. Okay, beta is rational, so y to the n over 2 is rational. So we have w is rational, e is rational, I is rational, and r is rational. But that's a contradiction for Fermat's right triangle theorem. That's what we were supposed to show. So go at it, boys. Let's see all your complaints. Thanks.